input socket on that panel around the back. There are also sockets on there representing letters of the alphabet, and you connect one to the other. So we start with our letters that we've worked out here. First, we reduce it to 12 pairs of letters. Then, what we do is we set up each one of these enigmas to represent one of the 12 pairs of letters. And to do that, well, let's say we want to represent the first pair of letters, W goes to Y, on this first enigma on the left. What we'll do is we'll connect the letter W on our panel to the input of this enigma. We'll connect the letter Y to the output of this enigma. For the next pair of letters, E goes to A. Similarly, we'll connect E to the input of the next enigma, A to the output of that enigma, and so on through the next pairs of letters. And when we run this machine, what's going to happen is each of these enigmas is going to try every possible combination, every position of every letter on the three wheels. And at some point, because this is an enigma, the input letter is going to produce the output letter that we're looking for. So on the first enigma, we're looking for letter Y to come out. It's a bit like having a human operator sat at a real enigma, constantly pressing the W very fast and only taking notice when the Y lights up on his machine. And for the second enigma, well, another human operator, another enigma, he's pressing E very fast, waiting for A to light up. Essentially, each one of these enigmas is going to try every combination. It's looking for a specific letter coming out of each enigma, each of the enigmas. And when we get a situation where every one of those 12 enigmas has the letters coming out that it's been told to look for, we have a combination that works. And then the machine stops and will give us a result. But the most important thing this machine is doing as part of the process is finding one of those patch cords from the front panel of the sender's Enigma machine. Alan Turing worked out a very cunning way of actually saying, well, we only need to find one, we can work out the rest later, rather than working out all 10 of the patch cords one time. And the process for the operator was very straightforward. Go to the pairs of letters that you've got and find the most prominent letter, the strongest letter. In our case, that would be the letter E that appears most often here. And then, back on the patch panel at the back of our bomb, we connect the letter E to the main input of the machine. And so when each of these enigmas is going to try every combination, the machine is also trying every possible combination for that patch cord, what letter E could possibly be connected to on the front panel of the sender's enigma. So you're doing that all at the same time. And when we run the machine, it looks like this. When the machine runs, it's going to try every possible combination, and it does it systematically. The top row of drums is rotating continuously. When the top row completes the whole alphabet, the second row moves on one letter position. Eventually the second row completes the whole alphabet, the third row will then move one letter position. And finally, once the third row completes the whole alphabet, you've tried every possible combination. There's 26 times 26 times 26 different possibilities. And the machine takes about 13 minutes to try them all. Unless, of course, it stops, like it did then, when it finds a combination that fits the bill. In other words, we've got a potential solution.